maximum. So theoretically, we are going to find what are those two frequencies where the power transfer is going to be maximum. So for that, I am substituting the expression for I2 max and equal to I2. So at this point, my maximum value is equal to the value of the current which is originally flowing, right? So I know the expression for I2 max and I'm substituting that equal to I2. So bandwidth we do 1 by root 2. Here we are not finding out the bandwidth. We are just finding out the frequency at which I2 max and I2 are same. Or we are finding the frequency when I2 is going to attain maximum values. So I need to solve this equation and find the expression for omega. What are the two frequencies omega where your power transfer is maximum? Now I2 max is this expression we have known, and I2 expression also we have derived. Take modulus for both sides and equate them. And is the values for the z parameters inside the equation is already we know that z11 is this one, z12 and 21 is mutual impedance, and z22 is going to be this one. So substitute everything in the above equation. So your RHS, LHS is going to be simple. Because I2 max we have derived, and RHS you substitute the expression for Z21, and denominator Z11 into 2 multiply minus Z12 square. So this is the equation what you get. And you know that the condition for maximum power transfer is this one. And we are not going to find the thing at resonance. We are going to find what is the maximum power transfer other than the resonant frequency. So you can see here, we will take M equal to B into MC and K is equal to B into KC. So we are going to use that expression for finding out the frequency. Since you know M and MC are not same here, in the presence of MC, I'll be substituting M by B. So in this equation, see here, R naught dash equal to omega naught square MC square by RA dash. Instead of MC, I'm going to put it as M by B because it is not going to be at resonance. It is going to be maximum power transfer not happening at resonance. Okay, so substitute omega MC equal to capital M by B. So you get R naught dash equal to omega square M square by B square into RA dash, or omega M is equal to B into root of RA dash into R naught dash. So here, substitute that here. So minus J V1 by root of 2 into R naught dash into RA dash equal to, wherever I have M, I'm going to substitute everywhere here. So here you have M, here you have M. So wherever I have M, I'm going to substitute that expression. Okay, and I'm going to simplify. So for simplicity, what I'm assuming L1 equal to L2 equal to L, C2 dash equal to C, and R0 dash equal to RA dash equal to R, and the LC tank circuit is going to be JX. Okay, for simplicity. So minus V1 by 2R equal to minus J V1 BR divided by R0 dash. R0 dash is going to be R, and this entire term is X. Okay, so R plus JX into this is also R plus JX. So R plus JX the whole square plus B square into R0 dash equal to RA dash equal to R. So it is B square